I may not be the best, but I am better than what I was yesterday.
Hi everyone. In the last video, we went through concepts on harmonic progressions and we looked at few simple problems. In this video, we'll go through few more problems which are a little tricky. So here's the first problem. If the fourth term of the HP is 3 by 4 and seventh term of HP is 2 by 3, find the 10th term. Now, whatever we have been given here for HP, we will have to first use arithmetic progression, right? Now, if fourth term in HP is 3 by 4, then fourth term in arithmetic progression would be reciprocal, which is 4 by 3. That is, you reverse the numerator and denominator. So it becomes 4 by 3, right? Now, similarly, seventh term of HP is 2 by 3. In HP is 2 by 3. Then seventh term in arithmetic progression would be 3 by 2. Now what we have to find? We have to find 10th term. We need to find 10th term, right? So what we will do? We'll first find 10th term in arithmetic progression, right? We'll find this one and then take the reciprocal, right? We'll take the reciprocal and that will become the 10th term in HP, right? Once you take the reciprocal. So now we'll use all of these values and try to get the 10th term. So we'll use the term formula in arithmetic progression. What is the term formula in arithmetic progression? It is a plus n minus 1 into d. Now we have fourth term. Fourth term would be, we don't know what is the first term. So we'll leave it like this. N is 4 here and we don't know what is d. So we'll get a plus 3d. Similarly, what is seventh term? It will be a plus n is 7. 7 minus 1 into d, which is a plus 6d, right? Now we'll have to find 10th term. So what we'll do, we'll take these equations, two equations, and subtract them, right? We'll subtract both these terms, subtract t7 minus t4, right? Why we do that is, let's first write seventh term, a plus 6d is equal to t7. Yeah, one more thing. The seventh term has been given, right? What is seventh term? 3 by 2. So, we'll have to write 3 by 2 is equal to a plus 6d. And here, fourth term is 4 by 3. So, we'll write 4 by 3 is equal to a plus 3d. Right? Now, we can call this as equation 1, this as equation 2. We'll subtract both of this. We'll take 3 by 2 is equal to a plus 6d. I'll just reverse it and write a plus 6d is equal to 3 by 2. This is seventh term. And then fourth term is a plus 3d is equal to 4 by 3. Now I'll subtract the whole thing, right? So when I subtract, this a and a will get cancelled. The reason I'm subtracting is so that I can get rid of a and a. Once I get rid of a, I'll be left only with d. Then I can find the value of d, right? So now 6d minus 3d will be 3d. And I'll have to subtract 3 by 2 minus 4 by 3. This is nothing but I'll take LCM as 6. 3 into 2 is 6. So to get 6, I'll have to multiply 2 with 3 times. But I have to multiply numerator. Here again, to get 6, I have to multiply 3 with 2. So I have to multiply numerator. So 3 into 3 is 9. 4 into 2 is 8. So I'll get 1 by 6. Now, if 3d is 1 by 6, therefore d is equal to, I have to shift 3 down here. So it will become 6 into 3, which is 1 by 18. So d is 1 by 18. So d is equal to 1 by 18. Now, I'll take any one of these equations. I'll either take seventh term or fourth term, any of these equations, substitute the value of d, right? So I have a plus 3d is 4 by 3. I'll take this equation. You can take any equation. I'll just take this equation. A plus 3d is equal to 4 by 3. I'll substitute the value of d, which is 1 by 18. This is equal to 4 by 3. Now I'll find the value of a, right? So 3 ones are 3 6 are. So a plus 1 by 6 is equal to 4 by 3. So a is equal to 4 by 3 minus 1 by 6. So a is equal to 4 by 3 minus 1 by 6. Again I'll take LCM. LCM would be 6. So this will go 2 times to get 6. So 8, this will go once. So 1. So I'll get 7 by 6. So a is 7 by 6. Right? Now we know a and d. So we can easily find 10th term now. Right? What is 10th term? This is an arithmetic progression. Remember, T10 in arithmetic progression would be a plus n is 10 into d. So a plus 9d. Now we'll substitute. What is a? A is 7 by 6. What is d? 1 by 18. So I'll get 7 by 6 plus half. 6 is the LCM. Once, 3 times. 7 plus 3. 10 by 6. 2 5s are, 2 3s are. So 5 by 3. So 10th term is 5 by 3. So this is in arithmetic progression. Now I have to find 10th term in harmonic progression. Just take reciprocal of this. Reciprocal of 5 by 3 is reverse it, 3 by 5. So this is the answer. So let's take the second problem. If fifth term is 1 by 5 and seventh term is 6 by 5, find the 10th term. So again, all these are in HP. We will convert this into AP. So in AP, fifth term would be a plus n minus 1 into d, which is a plus 5 minus 1, which is 4 into d. And fifth term is 1 by 5. But remember, we'll have to take reciprocal because this is arithmetic progression. So it will be 5 by 1, which is 5. So a plus 4d is 5. Let's call this as equation 1. Now we'll go to seventh term, which is a plus n minus 1, 7 minus 1, right, into d, which is a plus 6d. What is T7? 6 by 5. Let's take reciprocal. So it will be 5 by 6. You are reversing the numerator and denominator. 5 by 6 is equal to a plus 6d. This is equation 2. Now we will subtract. We'll subtract equation 2 and equation 1. The reason we will subtract is so that we'll get rid of a. A will get cancelled. And then we can find the value of d. So we'll take equation 2. 5 by 6 is equal to a plus 6d. And 5 is equal to a plus 4d. Now we'll subtract all throughout. So 5 by 6 minus 5. What is 5 by 6 minus 5? 6 becomes the LCM. So it will be 5 minus 6 times 5 minus 30, which is minus 25 by 6. So this is going to be minus 25 by 6 is equal to a, and a will get cancelled. A minus a is 0. 6d minus 4d is 2d. So we'll get 2d is equal to minus 25 by 6. Now I shift to this side. So it will become d is equal to minus 25 by 6 into 2. This is in multiplication. So it will become a division. This is in the numerator. So it will come to the denominator. So d is equal to minus 25 by 12. So d is equal to minus 25 by 12. Now we need to find a. So we substitute d in equation 1 or 2. Right? Let's take one equation. I'll take equation 1, which is a plus 4d is 5. A plus 4d is 5. And d is minus 25 by 12, which is equal to 5. 4 ones are, 4 threes are. So A plus, so plus and minus will become minus. 25 by 3 is equal to 5. So A will be 5. I'll shift this here. So it will be 5 plus 25 by 3. That is minus here. So if I shift, it will become plus. So now again I have to take LCM. LCM would be 3. This will go into 3 times. So 5 threes are 15. This will go once. So 25 ones are 25. So I'll get 40 by 3. So A is 40 by 3. Now we know both A and D. We can easily find 10th term in AP. Remember, it's in AP. 10th term would be A plus n minus 1, which is 10 minus 1 into D. And what is A here? 40 by 3. 9. What is D? D was minus 25 by 12. Minus 25 by 12. 40 by 3 plus 3 3s are 3 4s are. Plus and minus will be minus. 25 3s are 75 by 4. Now LCM would be 12. This will go 4 times. This will go 3 times. 40 into 4 is 160 minus 150, 225. So I'll get minus 65 by 12. This is 10th term. This is in AP. We'll have to find it in HP. So what is T10 in HP? Reciprocal. So swap the numerator and denominator. Reverse it. So it will be minus 12 by 65. So 10th term in HP is minus 12 by 65. So let's take this third problem. If A, B, C are in GP
And
A to the power x is equal to B to the power y is equal to C to the power z, show that x, y, z are in HP. Now first thing, how do we prove that x, y, z is in HP? Right? So if you have x, y, z in HP, then it means that y is equal to 2xz by x plus z. So if y, that is the second term, is equal to 2 into x into z by x plus z, then we call that these terms are in HP. Now we'll have to arrive at this particular expression. So what we will do first, we'll use what is given in the question. A, B, C are in GP. A, B, C are in GP. So in GP,
the common ratio is
B by A.
the common ratio between second term and first term is given as B by A.
Also,
The common ratio between C and B is given by C by B. This is the way we find common ratio in GP.
so now both of these values should give you
Same common ratio, right?
either you use second term by first term or third term by second term,
The common ratio is same.
which means we can say B by A is equal to C by B because the left hand side D values are same. Therefore, the right hand side values also should be same. That is B by A is equal to C by B. Now if I cross multiply, that is I want to get rid of the denominators. So I push the denominators to the numerators. That is I cross multiply. So B into B is equal to A into C. So I'll get B square is equal to AC, which means B is equal to square root of AC. Right? If I shift square here, it will become square root of AC. We have this particular expression also. A to the power x is equal to B to the power y is equal to C to the power z. Now let's assume that this is equal to some constant k, basically some number. So we'll generalize and put that number as k, which means ax is equal to k, by is equal to k, cz is equal to k. Now we'll use theory of indices, right? As per theory of indices, we can write this as a is equal to k to the power 1 by x. So I can take this power here, and if I'm shifting it to the other side, it will become 1 by x. Basically, it becomes a reciprocal. When you shift the power from one side to other side, it's going to become a reciprocal. Similarly, b is going to be x to the power 1 by y. C is going to become k to the power 1 by z. Now we have the values of a, b and c. Now what we will do, we have this particular expression. We'll substitute the values of a, b and c in this equation. So let's not take this as root. We'll take it as b square is equal to ac itself, right? Let's not complicate it. Let's keep this as the equation. B square is equal to ac. So instead of b, I have k to the power 1 by y. And then I have square here. Instead of a, I have k to the power 1 by x. Instead of c, I have k to the power 1 by z. Now this is nothing but power into this particular power I multiply, right? Using the law of indices, a to the power m into n becomes a to the power m into n. That is a to the power mn. So using this law of indices, we'll say 2 into 1 by y, which is 2 by y. This is in the form a to the power m into the a to the power n is nothing but a to the power m plus n. So we can write this as k to the power 1 by x plus 1 by z is k to the power 2 by y. Now since bases are same on both the sides, we can assume that the powers are also same, which means 2 by y is equal to 1 by x plus 1 by z. So x and z will be the LCM. So I have to multiply this with z to get this LCM, but I multiply the numerator. Similarly here I have to multiply with x, but I have to multiply with numerator. So z into 1 is z plus 1 into x is x, x, and this is equal to 2 by y. Now I'll take reciprocal because I want y in the numerator and 2 in the denominator. So what I'll do is, I'll take reciprocal, that is shift the numerator and denominator. So I'll make this as y by 2 is equal to xz by x plus z. Now I'll shift 2 here, so it will become multiply into, so it will get multiplied by 2. So y is equal to 2 into x into z by x plus z. Now this is what we need to prove, that this is in HP, right? What was the rule? We have to prove that y is equal to 2xz by x plus z. So we got this. Therefore x, y, z are in HP. Now let's take the fourth problem. If pth element of an HP is Q and qth element of HP is P, show that PQth element is 1. Right? So pth element. So first what we will do, we'll take a arithmetic progression. Pth element is TP. And what is TP here? Is Q. Right? It is 1 by Q. It is Q in HP. So in AP, it would be reciprocal, 1 by Q. So TP is equal to 1 by Q. And what is qth element? Qth element means qth term. That is TQ. TQ is P. But in AP, it will be reciprocal, 1 by P. And we'll have to show that, we'll have to prove that PQth element, that means TPQ, PQth term is equal to 1. This is what we'll have to prove. So what we'll do, now what is the term formula? It is A plus n minus 1 into D. Now pth term, so it will be A plus, instead of n, it will be P minus 1 into D. So this is nothing but, it will be A plus PD minus D. This is pth term. And pth term is, let's substitute, pth term is 1 by Q. Right? Now we'll come to qth term. Right? TQ is equal to A plus n minus 1 into D. Instead of n, we'll have to put Q. So TQ is equal to A plus Q minus 1 into D. So this will be A plus QD minus D. And what is TQ? TQ is 1 by P. In AP, right? It's 1 by P. So now we have equation 1 and we have equation 2. Now what we will do is, we'll try to subtract, right? Like we did in earlier problems. We'll subtract equation 1 and equation 2 so that we can get rid of this A. It's what we will do. So we'll take first equation, A plus PQ minus D is equal to 1 by Q. We'll subtract this with A plus QD minus D is equal to 1 by P. So this is equation 1. This is equation 2. So I'll subtract the entire thing. So A and A will get cancelled. Minus D, this will become minus and minus, it will become plus. So minus D and plus D will get cancelled. So I'll be left with PD minus QD is equal to 1 by Q minus 1 by P. So now if I take LCM, LCM would be Q into P. Simply multiply Q into P. Now if I have to get this LCM, Q into P, I have to multiply this into P. Only if I multiply Q with P, I'll get QP. But I have to multiply numerator. So I'll get P minus, here again, I have to multiply P with Q to get this LCM. But I have to multiply the numerator. So 1 into Q, which is Q. So P minus Q by PQ. And now I'll take D as common factor. So I'll be left with P minus Q. This P minus Q and P minus Q will get cancelled. But actually, I shift this here so that I get rid of the denominator. I'll get D into P minus Q into PQ is equal to P minus Q. Right? Now if you notice, P minus Q and P minus Q will get cancelled. This is in multiplication, so we can cancel P minus Q and P minus Q. So we'll get T PQ is equal to 1. There's nothing here, means it's 1. So if D PQ is equal to 1, so this indicates that D is equal to 1 by PQ, right? Difference is 1 by PQ. So we have found the value of D. Let's find the value of A, right? So we'll take any equation. Let's take equation 1 and substitute D, right? Instead of D, we'll put 1 by PQ. So I'll take this equation, A plus PD minus D is equal to 1 by Q. So A plus P, instead of D, I'll put 1 by PQ. 1 by PQ is equal to 1 by Q. So P and P will get cancelled. So I'll get A plus 1 by Q minus 1 by PQ is equal to 1 by Q. Now 1 by Q here, 1 by Q will get cancelled. So I'll get A minus 1 by PQ is equal to 0. So this means A is equal to, I'll shift this here, it will become 1 by PQ. So D is 1 by PQ. A is also 1 by PQ. Now we need to find PQth term. PQth term. The way we found Pth term and Qth term, we'll have to find PQth term. PQth term would be TPQ, which is equal to A plus n minus 1 into D. Instead of n, I'll put PQ. So we'll get PQ minus 1 into D. What is D? D is 1 by PQ. What is A? A is also 1 by PQ. Right? So I can take this 1 by PQ as common because both the terms have it. So 1 by PQ, if I take it as common, I'll be left with 1 here. And here I'll be left with PQ minus 1. So 1 and 1 will get cancelled. So I'll get PQ by PQ. PQ and PQ will get cancelled. I'll be left with 1. So we have proved TPQ is 1. We have proved that the PQth term is 1. Right? Now this is in AP. Right? In HP what it will be? It will be reciprocal. What is reciprocal of 1? 1 itself, right? 1 by 1 is 1 only. Therefore, this is proven that PQth term in HP is 1. So with this, we have come to the end of this particular video. If you've liked this video, do press a like and share it. Thank you.